discovered there are more than 140 million objects orbiting Earth, which is true, but there's a catch. Most of them are too small to track. So what does Earth's orbital environment actually look like when you analyze every object that we can reliably monitor? To find out, I downloaded data through the Space-Track Satellite Catalog, aka SATCAT, and analyzed the objects found within that catalog that we can reliably track. So why does this matter to you? Because every time you use GPS to navigate, when you check the weather, when you stream, whether it's on your mobile device or through your television, or even make a credit card transaction, you're relying on satellites orbiting hundreds of miles above the Earth. So what I discovered reveals just how dramatically Earth's orbital environment is changing, and why the commercial space boom is just getting started. Hello, I'm Dr. Amanda Fetch, aka Dr. Amanda Analytics, and I research artificial intelligence and space situational awareness. And on my YouTube channel, we use real live data, not just internet searched headlines, to better understand what's happening in space. Now today, we're going to establish a baseline of Earth's orbital environment using the same publicly available data catalog used throughout the space community for research and analysis purposes. Now the analysis you're about to see is entirely my own, done in Python. So with that being said, the data that we use comes directly from spacetrack.org. So if you'd like to follow along yourself, you're first going to need to create a free account on Space-Track. And then once you've logged in, you can navigate through SATCAT and the query builder. You can set the class to SATCAT and the format to CSV. Then you can simply click Build Query, then click Run Query to download the satellite catalog. Now I imported this information that came out into a CSV file into Python. I cleaned the data, reconstructed the historical catalog, which by the way dates back to 1957, classified every object, knew its orbital regimen, and created all of the visualizations that you're about to see. So what did this data actually show? As of today, July 17th, 2026, the Space-Track catalog contains 69,926 catalog space objects. Of those, 35,368 have already re-entered Earth's atmosphere and decayed, leaving 34,558 objects currently in orbit. Now that's important to remember that these aren't just active satellites we're talking about. Now the catalog also includes inactive spacecraft, rocket bodies, and orbital debris, which gives us a much more complete picture of the environment surrounding our planet. Now let's look at the bigger picture here. So this chart that I pulled together shows the growth of the entire Space-Track catalog from the beginning of the space age in 1957 through today. Now the blue line represents every object that, again, has been cataloged through this set, and the orange line shows objects that have decayed, and the green line represents everything that's still orbiting the Earth now. Now what immediately stands out is how dramatically the curve changes over the past several years. Now with that being said, that growth is not gradual. There's a sharp acceleration that begins around, let's say, 2020. Now Earth's orbital environment isn't just growing, we're expanding at a pace we've never seen before. Now the next chart that I pulled helps explain why. So when you look at this, we're seeing the number of cataloged objects added per year. Now for decades, annual launches fluctuated, but again, beginning in around the early 2020s, those numbers increased dramatically. Now in 2025 alone, 4,666 new cataloged objects were added, the highest annual increase in the history of the catalog. Even with only partial data for 2026, through today, July 17th, 2026, more than 2,500 additional objects have already been cataloged. Now again, this is a little bit more than just historical past trends. There's a fundamental different era pretty much occurring in space activity. So where are all these objects? More than 81% of everything currently in orbit, over 28,000 of those objects, is located in LEO, low Earth orbit. Now by comparison, only 965 objects occupy geosynchronous orbit. 963 are in medium Earth orbit, and 676 are in geostationary orbit, which means that the overwhelming majority of satellites, debris, and rocket bodies are concentrated within the same orbital regimen that supports many of the services we depend on every day, which is how I started this video. Now, when you break down the catalog by object type, the picture becomes even more interesting. Of that 34,558 objects, currently, I should say, in orbit, nearly 19,600 are payloads, representing active and inactive satellites. Now, another 12,529 objects are classified as debris, and more than 2,400 are rocket bodies left behind after launches. Now, perhaps the most striking statistic is that nearly 10,000 pieces of debris are currently orbiting within low Earth orbit alone. Now, every one of these objects contributes to an increasingly complex orbital environment that has to be continuously monitored. Hence why space situational awareness has become so important to all of us. Now, with that being said, we're not just launching new satellites at this point. Now we're building on an increasingly dense and interconnected orbital ecosystem that includes commercial constellations, government missions, scientific spacecraft, rocket bodies, and along with it comes debris. Now, understanding how that environment is evolving is essential for protecting critical infrastructure, ensuring safe space operations, and supporting the technologies we rely on down here on Earth every single day. Now, the analysis that I had done establishes a baseline of behavior. Now, we know how many objects are in orbit, where they are located, what they are, and how rapidly the orbital environment is changing. Now, as I dig into future videos, I'm going to continue to dive into what's driving this growth. I'm going to look at examining the impact of commercial satellite constellations, explore the debris problem, and analyze how Earth's orbital environment is likely to evolve over the coming years. Now, with that being said, I'd like to leave you with a discussion question. Would love to know your thoughts. As Earth's orbital environment continues to grow, what concerns you the most? Now, if you enjoyed this analysis, be sure to subscribe for more data-driven insights into AI, space, and emerging tech. Until next time, keep looking up and keep asking questions. I'm Dr. Amanda Analytics signing off. Take care.